Hello everyone, thank you for joining this session. Declarative configuration for API management allows organizations to scale efficiently, but it is not a silver bullet. At Checkr, we faced additional scenarios where declarative configuration is not suitable by design. In this talk, we will look into these cases and walk through the architecture that addresses them. But before we get started, a quick introduction. My name is Rylach, and I work as a staff software engineer with platform team at Checkr. I am passionate about designing and delivering complex enterprise-level distributed systems, keenly focused on high performance, scalability, security, and quality of those. Let's go over our agenda for this session. First, we'll talk about Checkr. Then, we will review an imperative approach for API management and its challenges. We'll talk about how declarative approach can address them, but of course, it has its own limitations. After that, we will review the hybrid model, which brings us to the global control plane. And now, let's dive right into it. So what is Checkr? Checkr is the leading technology company in the background check industry. More than 15,000 enterprise companies rely on Checkr to deliver the most accurate and timely results. We provide various ways for the complete background check and screening workflows. Each of them is suitable for the needs of your company. For example, large enterprises prefer having a direct access to API. Smaller companies do not have the same resources, so we help them by providing customer dashboard. Some of our clients use applicant tracking systems or human resource information systems. We also support direct integration with these solutions. Every candidate can view their own reports and work with our candidate success team, should they have any questions. To protect all of these solutions, we support both API key authentication and bearer token authentication. As you can see, we need a way to manage our APIs efficiently to support organizational growth. As company grows, the challenge of providing standard processes for managing APIs becomes more and more critical. API Gateway is a common architectural pattern to address it. It sits between your clients and API providers and acts as a single entry point for the traffic into the system. This centralized solution allows organizations to set up a governance model, which puts requirements on how the traffic is routed to servers and what are the security requirements for this traffic. It also helps you to enforce service license agreements and provides auditing and analytics. At Checkr, we chose Con as our API gateway because of its resiliency, performance, and plugin ecosystem. Originally, when Con was presented into the system, the organization was quite small, and the imperative management was enough for one team to handle API gateway. If you wanted to make a change to it, like presenting a new route or changing the rate limit, you could just access GUI. At some point, we had to present a user acceptance testing environment, so customers and partners could evaluate Checkr API ahead of the main launch. This setup was manual and prone to an error. Engineering teams ran into situations where API gateway was configured in an inconsistent way from one environment to another. Teams would enable some functionality in production and miss it in UAT. This solution did not allow us to deploy the system efficiently across regions either. We had to rethink the whole approach. We needed a solution which would allow us to deploy the system without manual steps, allow us to view the history of changes, require a review and an approval from other members of the team, and be available across regions. Declarative way of managing configurations was the winner. Luckily, Con ecosystem provides tools that allow us to switch from imperative management to a declarative one, specifically DEC, which stands for Declarative Configuration for Con, and Con Kubernetes Ingress Controller. Both of us both of them enable us to store con configuration in files which could be tracked with Git. Con ingress controller additionally allows us to express all configurations using custom resource definitions. Since we have been using Kubernetes and Helm to handle our workloads already, we decided to pick Con Kubernetes ingress controller to help us with this challenge. Helm on its own is already an extremely powerful tool. Helm natively supports inheritance of declarations. We use Helm to do templates to create Kubernetes ingress rules via CRDs. We then apply con plugins to ingresses once in the parent values file. During the deployment, we only need to override target host names for different environments and regions. This approach allows us to guarantee identical topology for the system while being flexible enough to deploy it anywhere. As it was mentioned before, we'll leverage con to authenticate an incoming request by validating an API key or an authorization bearer token. Every single API key must be associated with a con consumer so we can enable rate limiting per application identity. Since new developers and partners can sign up for the platform in a self-serving manner, we cannot manage API keys and consumers using declarative approach. By design, as we discussed previously, it requires manual intervention, which would negatively impact user experience. Developers should be able to invoke our APIs as soon as they sign up. Enter the hybrid API management model. During the migration to declarative configurations, we also had to upgrade our platform from an antiquated version of Con to the latest one without any downtime. Specifically, this upgrade required us to go through multiple major Con versions. During switch to the new major version, we would have to restart our Con data plane, what increases risks of something going wrong. We also needed a rollback strategy without any customer impact. Thereby, we decided to completely isolate Con data planes and bring up the latest Con version in parallel to the old one. A switch between Con data planes was driven by DNS configuration. With isolated data planes, management of consumers and associated API keys and plugins turns into a distributed transaction challenge. Meaning, if propagation of changes failed in one of data planes, we would need to roll it back in all others. To guarantee eventual consistency between multiple Con deployments, we decided to implement a total order broadcast pattern, which requires a persistent queuing mechanism like Apache Kafka. At Checkr, we have been using Kafka for a while now to orchestrate background checking and screening workflows. In the solution that we have designed, App Identity Service publishes all app changes to a Kafka topic. Consumers Controller, which is responsible for management of Con consumers and associated plugins, has one deployment per corresponding Con control plane or admin API, and comes with its own Kafka consumer group. Kafka guarantees orders of messages per partition. Hence, to make sure that all changes for a given app are processed in the same order as they have occurred, App Identity uses the app unique identifier as a topic partition key. This architecture allows us to apply changes to all app identity across multiple Con control planes in parallel. As you remember, we had another requirement, cross-regional support. The option to propagate Con consumer changes through Kafka helps us to have multi-regional deployments of the system as well. We leverage Kafka Mirror Maker to replicate a Kafka topic into another region, where we deploy local consumers controller. With this setup, all deployments across all regions become topologically identical. The only difference is the producer of events in Kafka topic. In the main region, it is App Identity Service, while in other regions, it is Kafka Manager. Now, Let's put it all together. As a result, we have gotten a hybrid system with a global control plane, where routing configurations, which do not change frequently and require auditing and manual validation, are being stored using Git. Consumers, their API keys, and rate limiting settings are propagated into Con automatically, with guarantees of eventual convergence towards the same state. So what is the new process for the rest of organization and engineering teams? They expose APIs of their new services by using Helm templates for Con Kubernetes CRDs. Helm files are stored in the same repository as the application source code. All changes to the traffic routing follow standard software development lifecycle. Everything around API authentication and authorization is supported by a single team, identity and access management. With this, the described architecture delivers on all requirements that we have set in the beginning. On one hand, we enable an efficient growth of the organization, and on the other, we have automated deployments of the platform to any environment and region. I hope you enjoyed this talk and found it insightful. Contents of the session are also available on Medium. If you are interested in building a fairer future, check out our careers page. And now, we are ready to take questions. Thank you.